my name is Johana Ligtenberg, and I am here to talk to you about the colonization of Mars. A few months ago, when I went to sing with my dad, he told me about an article. It was an article about Elon Musk landing rockets on barges in the ocean. My dad told me a little bit more about Elon Musk and his innovative projects, but what really stuck with me was something else he said. He told me that at the rate science and engineering are moving, within my lifetime, I will see the first person on Mars. And that is something that I've retained. Through a year of physics and an award season where we saw the movie The Martian's success, my curiosity about how that is possible has only continued to grow. So today I'm going to talk about several aspects of the possibilities of the exploration and colonization of Mars. First off, is it possible? Secondly, why Mars? And thirdly, how is it possible and what are the complications? First off, is this even possible? My generation's great-grandparents were alive when the first plane took flight in 1903. Within my lifetime and within 200 years of the very first flight, how can it be possible for me to see the first person landing on a planet nearly 55 million kilometers away from Earth? At the rate science and engineering are moving, it's possible for there to be a human population on Mars in the next 25 years. NASA is planning on developing an Earth-independent colony on Mars by the 2030s. Elon Musk, CEO of SpaceX, predicts his company could pull this off nearly 10 years quicker. He is looking to put people on Mars and begin developing a colony by 2026. But most importantly, why Mars? Why are scientists and engineers investing so much time and money into sustaining life on a planet where life has failed to develop on its own? Mostly, it's Mars' similarity to Earth. Mars and Earth have a similar day length. It is only a little over Mars' day length is only a little over 24 hours. It has an atmosphere and many other physical Earth-like characteristics, including mountains, valleys, dust storms, wind, sunshine, and most importantly, water. Two of the most important characteristics that a planet must provide in order to support humans that we cannot sustainably engineer or supply are water and an energy source. NASA's Curiosity rover has provided evidence that Mars was once home to water stored in lakes. Despite the fact that there is currently no usable water naturally occurring on Mars, this evidence proves that its atmosphere and physical makeup were once capable of sustaining and conserving water. This also shows that Mars, at one point, however many billions of years ago, did resemble Earth even more closely than it does nowadays. Though it is further away from the Sun than our planet, Mars isn't so far away that sunlight will not reach it. The Sun supplies most of the energy on Earth, so it is essential that at this point we will have sunlight on any planet we want to colonize. Mars once had a habitable environment. Scientists predict that Mars experienced ice ages similar to that of Earth due to their similar makeup, but that due to Mars' extended distance from the Sun, they were significantly more severe than Earth's were. This contributed to the harshness of Mars' current climate. Humans also, of course, need oxygen. The next rover that NASA is planning on sending to Mars will include a mechanism that can create oxygen and carbon monoxide with resources from Mars' atmosphere. There's also the issue of temperature differences. Mars' atmosphere is thinner than Earth's, which means it cannot retain heat as well, and so it's a much cooler climate. The average temperature on Mars is around negative 80 degrees Fahrenheit. However, winter on Mars can be as cold as negative 195 degrees and summer reaches up to 70 degrees. How is it possible? Both NASA and SpaceX are aiming to put people on Mars in the next 25 years. As you probably already know, NASA already has a rover on Mars. Their developments with the generation of oxygen, as well as their experience with putting vehicles into space, put them mostly on course with their schedule. While each organization is developing technology at a rate that makes their goals reasonable, although maybe far-fetched, there are additional complications to the journey that will need to be addressed before we will be seeing humans on Mars. First, there's the trip. Currently, it's an 8-month trip, which NASA would like to cut in half. The quicker the trip, the lower the risk of radiation poisoning during the expedition. Radiation exposure is the other major concern. Radiation is classified as energy in the form that travels in the form of waves or high-speed particles. Brief exposure to high amounts of radiation can cause burns or radiation sicknesses, the latter of which present itself in a variety of frightening effects. Brief exposure to radiation over an extended period of time can raise risk of cancer or cause genetic mutations that can be passed on to one's children. So what do you think? Will you or your children see the rise of a human colony on Mars? Right now, humanity may be in the early stages of our exploration of space, but as soon as the next 10 years, or when I'm 25 years old, it may be possible to see humans on the red planet. While there are a variety of complex reasons we want to colonize Mars, I see it as the mark of the curiosity and innovation of the human mind, and of course, the resilience when it comes to surviving in unrelenting environments.